So in this class, we will solve a problem on finding the extreme points of a given function. It is a question paper problem. Of course, it comes under non-linear programming only. The question is like this: find the extreme points of the function z is equal to, it's a function of two variables x1 and x2, x1 cube plus x2 cube plus 2x1 square plus 4x2 square plus 6. This is the function. So this is a question in VTU January 23. Of course, here they have not given any constraints, so it becomes an unconstrained optimization problem. So extreme points means we have to find out the values of x1 and x2 for which the value of this function becomes minimum and maximum. So we have to find out the values of x1 and x2 for which this given function has attained the minimum and maximum values. So you know in the differential calculus that the necessary condition for a function to attain minimum or maximum value is the first derivative of the function should be 0. Here, since it is a function of two variables, we have to take the first derivative, say partial derivative now. Dou z by dou x1 is equal to 0. This is one condition. Dou z by dou x2 is equal to 0. This is second condition. So because x1 and x2, they are the variables. Now if you do the first differentiation, partial differentiation of this given function with respect to x1, we have to treat x2 as constant. So it becomes 3x1 square, this derivative of this becomes 0, plus this is 4x1, derivatives of these two become 0, is equal to 0. This is the equation we are going to get. So if you simplify this, I can take x1 common, x1 into 3x1 plus 4 is equal to 0. So the thing is either x1 will be 0 or 3x1 plus 4 should be 0. So therefore x1 is equal to 0. Another value is minus 4 by 3. x1 will be minus 4 by 3. So these two are the values of x1. You may have minimum or maximum, that we have to find out later. Now the second condition is dou z by dou x2 is equal to 0. If you use this, once again we have to differentiate this with respect to x2, treating x1 as constant. So derivative of first term becomes 0. Second term derivative is 3x2 square. Derivative of this will be 0 plus derivative of this will be 8x2. Derivative of 6 is 0. Therefore it is equal to 0. Now here also you can take x2 common. So it becomes 3x2 plus 8 is equal to 0. So once again we can written as x2 is equal to 0 or 3x2 plus 8 is equal to 0. It means x2 is equal to 0 or minus 8 by 3. So these two are the values of x2 for having that function to be either minimum or maximum. Now, what we have to do here is, we have got two values of x1 and x2. That means there are four chances of having the values of x1 and x2 combination. So the first combination what I take is, when x1 is equal to 0, this is the first combination I am going to take, and x2 is also equal to 0. x1 0 and x2 0, that is the first combination. If I use this combination, so the value of z will become if you substitute the value of x1 and x2 here as 0 and 0, the value of z becomes 6. So this is the first value of z. For the second set, I will take x1 is equal to 0, but x2 I am going to take minus 8 by 3. Okay? I will take this combination. In that case, the value of z will be, so substitute for x as 0, for x1 as 0 and x2 as minus 8 by 3 here. So you will be getting 0 plus minus 8 by 3 whole cube plus 2 times 0 because x1 is 0 plus 4 times minus 8 by 3 square plus 6. This is what we are going to get. So if you simplify this, you are going to get the value of z as 15.48. So this is for the second set of x1 and x2 values. Now the third value of z is when x1 is minus 4 by 3 and x2 is 0. So this is the third combination you can have. In this case, the value of z becomes x1 is minus 4 by 3, so whole cube, plus x2 is 0 here, so x2 cube becomes 0, plus 2 times minus 4 by 3 whole square, plus 4x2 means once again 0, plus 6. So if you simplify this, you are going to get the value of z as 14.3. This is the third value of z. Next, fourth value of z, I will take x1 as minus 4 by 3 and x2 as minus 8 by 3. That is the fourth combination. If you substitute these things in z is x1 cube, which is minus 4 by 3 cube, plus x2 cube minus 8 by 3 cube, plus 2x1 square, 2 into minus 4 by 3 square, plus 4x2 square minus 4 into minus 8 by 3 square, plus 6. So if you simplify this, you are going to get z as 16.667. So these are the four values of z we got by taking the combinations of x1 and x2. Among these four values, the maximum value is this 16.667. So now after this, and of course minimum value is 6. So if you take the combination, so you are going to get like this. We have got a minimum value of z as 6 and maximum value of z as 16.667. 16.667. Of course, these two values we got. This first value we got at x1 is equal to 0 and x2 is equal to 0. Second value, maximum value we got at x is equal to minus 4, x1 is equal to minus 4 by 3 and x2 is equal to minus 8 by 3. Now let us check this. So after getting this, you can check these values whether it is correct or not by using the second derivative, sufficient condition. Necessary condition for a function to have minimum and maximum values, first derivative should be 0. Sufficient condition is second derivative we have to calculate. If the second derivative value at these points, if it is positive, then it is minimum value. If it is negative, it is maximum value. Now let us check the sufficient condition. For that we have to take the second derivative of z with respect to both x1 and x2. So it is written as dou square z by dou x1 square. So we have dou z by dou x1 as this 3x1 square plus 4x1. So once again I have to differentiate this with respect to x1. You will get 6x1 plus 4 is equal to this is the value. Similarly, you have dou square z by dou x1 square, dou x2 square we have to take the second derivative of this dou z by dou x2, which is 6x2 plus 8. 6x2 plus 8. Okay, like that we got. Now let us substitute the values of x1 and x2 in this. So we have got two values of x1. One is 0, another is minus 4 by 3. So we will get two values here also. If x1 is 0, so this value that is dou square z by dou x1 square will be 4. If x1 is minus 4 by 3, then dou square z by dou x1 square will be 6 into minus 4 by 3 plus 4. That means that is, if you simplify that, you are going to get, I think, 4. Not 4, you are going to get 0. Isn't it? So, we are getting 0 there. 6 into minus 4 by 3, or not 0, sorry, 2 into minus 4. Minus 4. So, here you can observe that when x1 is 0, you are getting positive value 4. When x1 is minus 4 by 3, you are getting a negative value minus 4, which is less than 0. Now on the same lines, if you calculate this second derivative value, once again you have two values here. For x2 is equal to 0, dou square z by dou x2 square will be 8. Once again it is positive greater than 0. Then if for second value x2 is equal to minus 8 by 3, dou square z by dou x2 square will be equal to 6 into minus 8 by 3 plus 8. So if you simplify this, you will get minus 8, because this is minus 16 plus 8. So it is less than 0. So these are the values of second derivatives for the obtained values of x1 and x2. Now if you observe these things, one thing you can say that since this is positive, you can expect minimum value here. Minimum value. Since this is negative, you can get maximum value. You can expect maximum value. Since it is positive here, once again, you can expect minimum value. And since it is negative, you can expect maximum value. So as we know, if the second derivative is negative, you can have minimum value. If the second derivative is positive at any point, then it is maximum. If the second derivative is positive, it is minimum value. If the second derivative is negative, it is maximum value. So if you use that criteria, you can see here, when x1 is 0 and x2 is 0, we have the minimum value. And when x1 is minus 4 by 3 and x2 is minus 8 by 3, we have the maximum value. So that's what we have got here also. You can see minimum value of z, we got 6. 6, that is the minimum value occurs at x1 0 and y1 x2 0. Maximum value of z is 16.667 among these four values, which is occurring when x1 is minus 4 by 3 and x2 is minus 8 by 3. So that is the conclusion we can draw. So therefore, so these two are called as the extreme points. Extreme points means for x1 and x2, the extreme points are for x1, the extreme points are 0 to 0 and minus 4 by 3. For x2, the extreme points are 0 and minus 8 by 3. So this is the answer for the given problem. So this is a simple problem wherein we are using the necessary condition and sufficient condition for finding the minimum and maximum value of a given function.